Hello, Honors Algebra students. Mr. Lawrence here. I hope you're enjoying your snow day. Here's a little bit of homework help for problems 12, 13, and 14. They're very simple. What you have to remember is, what have we been studying? We've been studying factoring. Factoring is going to be involved in these problems. Now, by the way, when you watch this video, you should pretend like you're being in class, playing school, so to speak. Have your notebook out, your pencil or pen ready to go. Pause the videos you need to, rewind parts, ask somebody to listen with you if you don't understand something. Okay, you can't just watch it like you're watching a TV show where you veg out and 20 minutes later you can't tell anybody what you watched. Okay, you've got to be proactive in your learning. All right, so this says the measure of the area of a rectangle is 16x squared minus 121 centimeters squared. What is the perimeter of the rectangle? By the way, I've cleaned up the two mistakes I was aware of with the problem, so with the worksheet. So that worksheet is very well done and can help you learn if you use it right. You know, we had a student on, let's see, what would that be, Tuesday, that just walked in and started doing the problems and totally bypassed the first two pages. Those first two pages explain what's going on with each type of factoring. I would definitely go back and take notes on it, maybe reread it, whatever you need to do. Like I said, I've cleaned up the two mistakes. All right, anyway, so I know the area of this rectangle is 16x squared minus 121 centimeters squared. And I also know that to get the area of a rectangle, we can use the formula base times height. Some of you like to use length times width. I don't like that, but that's okay. It still works. Sorry, I was talking about length and width, and so I started to write width. Height. There we go. Now, if you think about it, if I have x plus plus 3 and x minus 5, that's a situation where I need to double distribute, right? I know you think I've gone off on a tangent, but come along with me. So I'd get x squared. Let's see, I think I'm going to get a minus 2x and a minus 15, right? Well, I just multiplied a base times a height. Some of you are like, well, how do you know they're the base and height? Because it says to multiply two things together. That's it. That's all it is. This is one number. This is another number. I don't know what the numbers are because I don't know the value of x. But I'm just going to take those two things, multiply them together, and then this can be my area. Well, in this problem, I'm working backwards. I'm given 16x squared minus 121. And I have to figure out what two things were multiplied together, double distributed, to get me this answer. Well, I'm going to factor. Yeah, factoring is the inverse of distribution. And so I look for a GCF. Watch these steps, GCF. Okay, GCF. The GCF is only one, so that doesn't work. Now, since it's a binomial, there's only one other way it can possibly factor, and that's by the difference of perfect squares, right? Difference of perfect squares. So I'm going to check and see if it fits that pattern. If not, it's prime, and I can't do this problem using factoring. Okay, so let's see. This is a perfect square. The square root is 4x. And this is a perfect square. 11 is the square root. And sure enough, there's subtraction right there. This is going to factor as 4x plus 11 and 4x minus 11. Well, this side can be the base, and this side can be the height, or it could be the other way around. It doesn't matter. Okay? So, if I know that this is 4x plus 11, and this side is 4x minus 11, I can figure out the perimeter by taking a walk around the rectangle. So let me get some highlighter out here. Hold on a second. All right. So if I walk this distance, how far have I gone? Well, I've gone 4x plus 11 units, or centimeters, I think, in this problem. Now when I come here, I'm up to 8x, right? But my 11s have canceled out, so I've walked 8x centimeters. And now I go another 4x plus 11. And so that would be 12x plus 11. And then when I go here this distance, I go another 4x. So I'm up to 16x. 16x. But there's a minus 11 there because those sides are congruent, right? It's a rectangle. And so it's just 16x centimeters is the perimeter of the shape. Okay, that's problem 12. I'm going to do problem 13. I'm not going to do problem 14 because you're going to do it. Okay, so let's see here. You have a square picture frame. Okay, and so that's pretty close to being square. The opening for the picture is an unknown amount of inches. Hold on a second here. Let me make this a little bit smaller. I started to draw the wrong picture, but that's okay. All right. So now there's a border around this. Right? Oh, by the way, it says it's an unknown amount of inches. So I'm going to call this distance x. I can get the area of that little square, right? It would be x squared inches squared. All right. Now there's a border going around it. So let me get another. It's not centered, but it's close. Well, that's pretty close. And it tells me that the border is 4 inches wide. Right? So it's 4 inches all the way around. Okay, so how long is it from here to here? Well, it's 4 plus this x plus 4. So this side, the sides are actually x plus 8. And since it's a square, I know all 4 sides are x plus 8. So if I do the area of the bigger square, the border, I will get x plus 8 times x plus 8. That'll be x squared plus 16x plus 64 inches squared. Now, it's a picture frame. So this part here is open, right? Because that's where the picture has to go. So there's no material there. The frame is not included there. It's as if that hole has been cut out. Well, cutting out is like subtracting. So all I'm going to do is take the area of, I should do that in green, sorry. I should take the area of the big square, and I'm going to subtract the area of the little square. And so in this problem, I'm going to get x squared plus 16x plus 64, that of course is in inches squared. And then I'm going to subtract x squared from it. I like to do things vertically, as I've told you, my addition and subtraction, and so that's why I'm lining it up this way. These are canceling. The area of the frame is 16x plus 64 inches squared. And there you go. Okay. Problem 14 is sitting right here. Very similar problem. Let's see if you can go ahead and do it. Okay, here comes my solution. Again, I'm going to draw a picture. And I know that's x plus 2. And there's a frame going around. And I know that this is 6 and this is 6. So let's see, I think this is going to be 6 plus x plus 2 plus 6, which is going to be x plus 14 on each side. So I'm going to have x plus 14 for the big square. Again, if you haven't tried this, you should be doing it on your own. So I'm going to get x squared plus 28x plus 196. Now the little square, area of the little square, is going to be x plus 2 times x plus 2, which is x squared plus 4x plus 4. Okay? Now, I am going to subtract, just like in the last problem, but I have to make sure I subtract the entire area. So my subtraction problem is going to look like this. X squared plus 28x plus 196. I'm going to rewrite that. Hold on one second. Okay, I'll put that over here. All right. Minus, and since I want to subtract the whole thing, I'm going to put it in a quantity. X squared plus 4x plus 4. And since you have a minus in front of a quantity, you have to distribute. So all your signs are going to change. Now to take a vertical perspective on this, what it's going to get me is x squared plus 28x plus 196. And I'm going to end up subtracting x squared, 4x, and 4. And so my answer is going to be 24x plus 192. And I think we might be in centimeters. I don't remember. I think it's centimeters, but I wasn't sure I'd put units squared. Nope, it's inches again. So I should have put units squared because I wasn't sure, but that's okay. I checked my work, and so I can fix it. Mistakes are not an end-all be-all. They just an opportunity to correct my work. All right, there you go. Hopefully that video helps you out. Mr. Lawrence signing off. Have a good night, everybody.